Hello everyone, welcome to the channel. Today we will be discussing about the first principle of derivative. Generally, students memorize the standard derivative formulas which come via the first principle of derivative. But we usually ignore this. But ignoring this will cost us very badly. I'll show you some examples of questions asked in premium exams like JEE and ISI which will demonstrate my point. But before we see those questions, I want to quickly revise what is first principle of derivative. Now let's consider this graph y equal to f of x. We can see that this line is a secant to the graph cutting it at a and b. Now what is the slope of the secant? Slope of the secant is given as f of x plus h minus f of x divided by x plus h minus x. Now we can see that x is cancelling in the denominator. Now this is the slope of the secant. Now what will happen if I tend h to 0? H here nothing means it's the distance between these 2 points. Now as h will tend to 0, the point B will be coming closer and closer and closer to the point A, and finally this line will no more be a secant, it will turn into a tangent. What is the slope of tangent at the point x denoted as f dash of x? It is nothing but limit h tends to 0 f of x plus h minus f of x whole divided by h. Now this is the first principle of derivative. It is simple, but it will help us a lot in our problems. But before we go into the questions, I want to show you another form of this first principle of derivative. Now consider the same graph again. Let us consider a point A. From this point A, let us draw a secant to this graph. Let's say it will cut the graph at some other point x. Now what's the slope of this secant? Slope of this secant AB is f of x minus f of a divided by x minus a, as x will tend to a. This implies that this x will be coming closer and closer and closer to this point A. Point B will coincide with point A. And again, like before situation, this line will no more be a secant and it will turn into a tangent, which is represented as slope of this tangent is given as f dash of a, which is limit x tends to a f of x minus f of a divided by x minus a. Now our fundamentals are clear. Now we can dive into the problems confidently. Now you can pause the video here and try this JEE Advanced 2025 paper 1 question. After you pause, you can see the solution. Let us read the problem. Let R denote the set of all real numbers. Define the function f from R to R by f of x equal to this piecewise definition, which is broken down at x equal to 0 and x not equal to 0. Now they are asking which of the following statements is true. They are saying the function f is not differentiable at x equal to 0. Let us verify. Now if we use our standard derivatives procedure, let's differentiate this function and tend x to 0. Let us see what we will get in that situation. F dash of x is, now this x square and x square will be cancelled provided that x is not equal to 0. Now if I tend x to 0 in this situation, this 4x term will tend to 0. This 2x term will tend to 0. Sin 1 by x will anyways lie in between minus 1 and 1. So we will not get any problem of indeterminate form. Therefore this term will be going to 0. Now we will get stuck at the point where we need to calculate limit x tends to 0 cos 1 by x. Usually we know that limit x tends to 0 cos 1 by x is undefined, because at this point the graph will be oscillating violently between minus 1 and 1. So that's it, we can't even see the derivative at that point. But here we don't say that the function is not differentiable at x equal to 0, because the method we are following itself is wrong here. We are calculating f dash of x and tending x to 0, which means that we are seeing in the neighborhood of 0 how the f dash of x is behaving to estimate how it is at x equal to 0. But here it's not the case, because of that term cos 1 by x, the graph will be oscillating violently in between minus 1 and 1, and you can't comment about the derivative at any neighborhood of 0. So in order to come over this problem, we will use the first principle of derivative. Now they asked us the derivative at a specific point, so I will be using this definition. F dash of a is equal to f of x minus f of a by x minus a as limit x tends to a. Now let me see what's the given function f of x is. It is nothing but limit x Let me write it in a new line. Let's see, keep this as our definition. Now, f dash of 0 is given as f dash of 0 is equal to limit x tends to 0 f of x minus f of 0 divided by x. Now let us see what is f of x. F of x is nothing but 2 minus 2x square minus x square sine 1 by x when x is not equal to 0. Let me write that down. Limit x tends to 0, 2 minus 2x square minus x square sine 1 by x. Now what is f of 0? F of 0 in our problem is given as 2 minus f of 0, which gives us minus 2 whole divided by x. Now let us cancel these 2's and we can take an x square term out common from this, which will turn out limit x tends to 0, x square common minus 2 minus sine of 1 by x whole divided by x. We will cancel 1x. Now as limit x tends to 0, this part has no chance of spiking up to a value like infinity to give us an indeterminate form. It will always be a finite value. So as limit x tends to 0, the value will be exactly 0, which is f dash of 0 is equal to 0. It is the derivative at this exact point. Now you may ask, why didn't this method work before? See, as I told you, the graph was oscillating violently in between the values minus 1 and 1 as we consider the neighborhood of x equal to 0 and not the point x equal to 0. That is the reason we didn't get the answer in the previous method, but this method gave us the answer. Hope you understood. Now let us see the remaining options. Let us first see option D. It is more simple because we solved the part A. X equal to 0 is a point of local minima of f. We know that now f is differentiable at x equal to 0 and the derivative at f of x at x equal to 0 is 0. So now we can comment about the point is a local minima or a local maxima. Let us see. If x is not equal to 0, the function is defined as 2 minus 2x square minus x square sine 1 by x, right? Which is nothing but 2 minus 2x square plus x square sine 1 by x. This term will always be positive irrespective of any value of x, or at the least it will be 0. So 2 minus this thing will always be less than or equal to 2 itself. At x equal to 0, this will turn out as 2, and at remaining points when this thing is not 0, we will get a value that is definitely less than 2. Therefore, x equal to 0 is a point of local maxima of f, not local minima. So we can reject this option too. A and D are wrong. Now let us verify options B and C. Option B and C are just representing what I said just maybe 2 minutes ago. Let us see option B. It says there is a positive real number delta such that f is a decreasing function on the interval 0 to delta. As I said, this is not true because cos 1 by x will be oscillating violently in between minus 1 and 1 when we are considering any neighborhood near 0. Irrespective of how much our small delta is, it will be oscillating infinitely many times between minus 1 and 1. So it's not correct to say that the function is decreasing or increasing on a certain interval 0 to delta. Now let us see the option C. For any positive real number delta, the function is not an increasing function on the interval minus delta to 0. Yes, this statement is true. We can't comment on whether the function is an increasing function or decreasing function. This option says it's definitely not an increasing function. It is absolutely true because, as I said, the cos 1 by x is rapidly oscillating between the values minus 1 and 1. So the only statement that is true in this case is option C. The rest all are wrong. I hope you understood this question. Let us move into the next one. This is an PYQ of ISI examination. It was asked in UGB. UGB is nothing but the part in the ISI test paper which tests our subjective writing skills. we are supposed to write the proof of this problem, not only getting the answer. Okay, but now let's see how to solve this question via the first principle of derivative. Here the question says, suppose f from R to R is a continuous function. Here again f of x is given as a piecewise definition, broken down at x equal to 1. Now the question asks in part A, what is the value of f dash of 1? We already solved the first question of JEE Advanced paper 1, right? I hope you got an idea about how to deal with these type of situations. You can pause and try to solve this question and verify your answer. Now let us get into the solution. F dash of 1. They are asking us the derivative at a particular point. So I want to use the definition. I want to use this form of first principle of derivative. Limit x tends to a f of x minus f of a divided by x minus a is equal to f dash of a. Here a is nothing but 1. Now I will write this one. F dash of 1 is equal to. Now let us combine these two terms, e power x power 10 minus 1 and this minus 1. Because we will be using this formula, limit x tends to 0, e power x minus 1 by x is equal to 1. Here, since we have an x power 10 minus 1 and x is tending to 1, it will be resulting in the same format. Now let us see how we can present it. Now in order to reduce this thing, I will divide and multiply with x power 10 minus 1. Let me do it in the next slide. Let's continue. Now as I said, I will be multiplying with an x power 10 minus 1 and dividing in this term. Because I can write, since x is tending to 1, I can say that x power 10 will also tend to 1, which will imply that x power 10 minus 1 will tend to 0. Then that is the reason we can use the limit that I mentioned before, limit x tends to 0, e power x minus 1 by x is equal to 1. Let me write that down. Now as x will tend to 1, I can write this quantity as 1 itself, right? Yeah. Reducing it to 1, we get limit x tends to 1, x power 10 minus 1 plus x minus 1 whole square sine of 1 by x minus 1 divided by x minus 1. Now let us split the denominators. Limit x tends to 1, x power 10 minus 1 by x minus 1 plus x minus 1 whole square by x minus 1 will yield an x minus 1 in the numerator into sine of 1 by x minus 1. Now to evaluate this limit, you can either apply L'Hopital rule or factorize x power 10 minus 1 by x minus 1. In either way, you will get the answer as 10. Now when you evaluate this limit, as x is tending to 1, this quantity will tend to 0. And sine of 1 by x minus 1, how much ever it will oscillate in between minus 1 and 1, it will be a finite value, giving us a 0 as x will tend to 1. So our final answer is 10, which is f dash of 1 is equal to 10. In order to present this in a rigorous format in subjective proofs, you can show this thing is equal to 0 via squeeze theorem or sandwich theorem. This limit can be solved easily by factorization to show in your subjective proofs. Let us look at the second part. We got the value of first part is 10. Okay, now the part B says limit u tends to infinity. Looks like there is an error in the question. Let me rectify it. It is not 1000, it is 100 u. Let me write this part B in a new slide so that we can continue. Looking at this question, my first thought was this term looks like the one of the terms in the first principle of derivative, which we learned in the first slide of our class. Let me write it in the side. Limit h tends to 0. Substitute x equal to 1. We will get f of 1 plus h minus f of 1 divided by h. H is tending to 0. And here too, as u is tending to infinity, since k is a finite quantity from 1 to 100, k by u will also tend to 0. So it's looking like the term f of x plus h if we compare. So let me try to write this in the form of first principle of derivative and see what will happen. Now I will do a manipulation. I can write this 100 as sigma k equal to 1 to 100 into u minus u into sigma times k, sorry, not sigma times, sigma of k equal to 1 to 100 f of 1 plus k by u. Now I can do one thing, I will take the summation sign out. Sigma k equal to 1 to 100. I will also take the u out common because it is independent of k anyways. Now what I am left is with 1 minus f of 1 plus k by u. Yeah, that's it. Now we were given in the question that f of 1 is nothing but equal to 1. So I can write this 1 as f of 1. And also I'll take the minus sign out common. Minus u times summation k equal to 1 to 100 f of 1 plus k by u minus f of 1. Now in order to make it completely look like the first principle of derivative, let me multiply and divide with k by u. Now this whole thing is nothing but f dash of 1, which we calculated in our previous part is equal to 10. And also this u and this u will be cancelled. Since we need to substitute u tends to infinity at once, this all should have, in order to substitute this as f dash of 1, this u must be cancelled, and it got cancelled. Let us continue. Okay, no, there's no more need of writing the limit. It is just summation of, let's take the 10 out, minus sigma k equal to 1 to 100 k. Now evaluating this sum, we'll get 10 times minus 5050, which is nothing but minus 50500. It is the answer to our part D. Hope everyone understood. Now let us move to the next question. Now this question is different from the ones that we have seen before. Now if a student wants to take the derivative and then 10x to 0 to find f dash of 0, it's not possible for them to do, because here the domain goes like, if x is a rational number, then f of x will give us x squared. If x is irrational number, then we are getting 0. Whatever the function is, we will not panic and we'll just stick to our principles. Let us do the first principle of derivative. Let me write it up. Now since again they are asking the derivative at a specific point, I will use this definition. Here a is 0. F dash of 0 is equal to, now let us keep f of x as f of x itself, and f of 0 is nothing but 0 is a rational number, x square when x equal to 0 is 0. So we are left with f of x by x. Now as x is tending to 0, if x belongs to a rational number but not 0, f of x by x will look like this x. And if x does not belong to a rational number, f of x will go to 0 and we will get f of x by x is equal to 0. Yeah, so now I can write it up like this. Whatever happens, if x belongs to a rational number or it doesn't, f of x by x will lie in between x, and it will always be greater than or equal to 0. It will be 0 if x is not a rational number, and it will be, okay, let's consider the absolute value, since we cannot say that it will always be greater than or equal to 0 if we take out the absolute value. Yeah, now this statement is completely true. Now what I will do is, we will do sandwich theorem here. Let us apply limit x tends to 0 all over the inequality. Limit x tends to 0, 0 is nothing but 0, less than or equal to limit x tends to 0 mod f of x by x is less than or equal limit x tends to 0 mod x, which is nothing but 0. This implies that limit x tends to 0 mod f of x by x is equal to 0, which implies mod of f dash of 0 is equal to 0. So we can conclude that f dash of 0 is equal to 0. Hope everyone understood this problem. This problem was a bit different from the ones we solved before, but it is a beautiful question involving both sandwich theorem and first principle of derivative. I hope everyone understood. I was always using only this definition of first principle of derivative. I'll make another video in which I'll solve functional equations via calculus, in which I'll be using the other first principle of derivative, which will be a lot more helpful to solve those questions. See you in the next videos. Take care. Goodbye.